Hello students, I'm sure you all heard that light travels in straight line. It's called rectilinear propagation of light. But are you ready to try a magic trick with me where we are going to bend a light? So for this magic trick, I just need you to get a transparent glass filled with water. Okay, just pause the video, go and get the transparent glass filled with water. So are you ready with your glass of water? Next, I will show an arrow on the screen and you pause the button when you see the arrow on the screen. Now put the glass of water in front of screen and tell me what you see this time. Did you see the magic? Did you see that arrow changes the direction? Did you see the arrow changes its direction? Dear students, this is our magic. Did you say this? It's happening due to bending of light and it's called refraction of light and it's gonna be our today's topic. Now students will perform our next activity of refraction of light. For this activity we need a bowl, a colorful object and a glass of water. Okay, firstly I'll put this colorful object at the bottom of the bowl. Can you see it? Now push this ball away from you so that its wall just hide the object. Now stop pushing as soon as you lose the sight of colorful object. Now pour some water into the ball. So students, are you able to see this colorful object? Just look here, this pink color object is visible to you. This happens because in absence of water, the light from colorful object travels in straight line, but this wall hides it. But when I pour some water into it, wall is now this wall is unable to hide the colorful object because the light refracts coming from the colorful object and bends and it quite easily enter our eyes. So now students, I'm sure you are able to answer me that what is refraction of light? The change in the direction of light when it passes from one medium to another is called refraction of light. Clear? When light passes from one medium to another medium, it bends or it changes its direction. Now, what is the cause of refraction? The cause of refraction is that the speed of light is different in different mediums or substances. For example, speed of light in air is 3 into 10 raised to the power 8 meter per second, whereas that in glass is 2 into 10 raised to power 8 meter per second. So, all of you just see the speed of light in air is more as that of in glass. Okay, so the refraction of light is due to the change in the speed of light on going from one medium to another. So what is the cause of refraction? The change in the speed of light on going from one medium to another is the cause of refraction. Clear? Now we'll study about laws of refraction of light. For this, we introduce some terms This is medium 1. This is medium 2. This is interface between the two mediums. Now I draw a normal on the interface. Normal here is that is perpendicular to the surface. I draw a normal here. Now, when a ray of light is incident on the surface or on the interface of the two media, so this ray is known as incident ray. When a ray of light falls on the surface of the media, that is incident ray. So here this angle is known as angle of incidence. Angle I, that is angle of incidence. How can you define angle of incidence? The angle formed between incident ray and normal is known as angle of incidence. Angle formed between incident ray and normal is known as angle of incidence. Okay, now rays incident on this interface. Now when it enters medium number 2, then it changes its path. Suppose it follows this path. Okay, so that ray is known as refracted ray, and here this angle is angle R, that is angle of refraction. So how can you define angle of refraction? You can define angle of refraction as the angle formed between refracted ray and normal is known as angle of refraction. The angle formed between refracted ray and normal is known as the angle of refraction. Okay, now let's start the laws of refraction of light. According to first law of refraction of light, the incident ray, normal, and the refracted ray all lies in the same plane. Okay. Second law is the ratio of sine of angle of incidence to the sine of angle of refraction is constant for a given pair of media. I'm repeating, the ratio of sine of angle of incidence to the sine of angle of refraction is constant for a given pair of media. That is sine of angle of incidence divided by sine of angle of refraction is equals to constant. Sine I upon sine R is equals to constant. This constant is called refractive index. I'm repeating, the ratio of sine of angle of incidence to the sine of angle of refraction is constant, and that constant is refractive index. Okay, so first law is incident ray, normal, and refracted ray all lies in the same plane. Second law is the ratio of sine of angle of incidence to the sine of angle of refraction is constant, and that constant is refractive index. As the refractive index is ratio of both the same quantities, so it has no units. Okay, now do you know what is the sine? Sine of angle of incidence. What is the sine? It's a trigonometric ratio. Suppose I have a right angle triangle here. This is a right angle triangle ABC named. Okay. Here, this angle is theta. I want to find out the value of sine theta. This is a trigonometric ratio. All of you know that this is base of the triangle. This is perpendicular, and this is hypotenuse of the triangle. Okay, now to find out the sine of sine theta, this trigonometric ratio, I want to find its value, then sine theta is equals to the ratio of perpendicular to that of hypotenuse. Okay, it is defined as the ratio of perpendicular to that of hypotenuse. We will be learning in the chapter trigonometric ratio of mathematics. Okay, so now students, the value of this constant will change when you change the value of these mediums. Or suppose this medium is air and second medium is of glass. Okay, for this I will write the value of sine of I upon sine of r. Suppose it is equals to x, it's a constant. Okay, now I'll replace second medium with that of water, or you can take anything. Okay, now the value of ratio of sine of angle of incidence to that of sine of angle of refraction will be z. Okay, so when we change the mediums, the value of refractive index also get changes, the value of this constant also gets changes. You can conclude that it is concluded that refractive index of different mediums is different. Now look at the interesting activity of refraction of light. I have a bottle filled with water and a laser light, and there is a hole in the bottle and water is flowing out from this hole. Note that when the laser light falls on the hole, just notice that the laser beam follows the flow of water and the beam crashes down along with the water into the ball. Refractive index is also defined in terms of speed of light. As all of you know that light is refracted in going from one medium to another because its speed changes. It slows down or it speeds up. Due to this, the refractive index can also be written as the ratio of speeds of light in the two media. Now suppose again this is interface between the two mediums. This is medium 1 and this one is medium 2. Now I draw a normal here. Let us suppose the speed of light in medium 1 is v1 and speed of light in medium 2 is v2. This one is incident ray. Its speed is v1. When it goes from one medium to another, it changes its path with speed v2. Okay, now you want to find out the refractive index of medium 2 with respect to medium 1. Then you can write refractive index of medium 2 with respect to 1. Okay, you want to find out the refractive index of medium 2 with respect to medium 1, then you can write it as refractive index of medium 2 with respect to 1. Then it is equals to ratio of speed of light in medium 1 to the speed of light in medium 2. That is mu 21 is equals to v1 upon v2. You can see here the refractive index of medium 2 with respect to medium 1 is equal to the ratio of speed of light in medium 1 to the speed of light in medium 2. Nu 21 is equals to V1 upon V2. Okay. Now, what is the unit of this refractive index? Can you tell me what is the unit of this refractive index? Okay. Now, as you know, the unit of speed is meter per second. Again, the unit of speed in medium 2 is also meter per second. Both will cancel out. So, refractive index have no unit. Clear? Now, suppose you want to find out refractive index of medium 1 with respect to medium 2. So, this can be denoted like this: mu 1 2, it is equal to refractive index, speed of light in air, speed of light in medium 2 to the ratio of speed of light in medium 2 to the speed of light in medium 1. Clear? As you have seen that these are the reciprocal of each other. Now, I named this term, this equation as equation number 1, and this is equation number 2. Now, reciprocal, do the reciprocal of equation number 2. What we will get? 1 upon mu 1 2 is equals to mu 1 upon mu 2. Now, from equation number 1, put the value of V1 upon V2 in it. Okay, what we will get? 1 upon 2 mu 1 2 is equals to mu 2 1. Both are reciprocal of each other. Okay. Refractive index of a medium. Obviously, the medium is placed in air or in vacuum. So, the refractive index of a medium is equals to speed of light in air or in vacuum divided by speed of light in that medium. Okay, when it is not mentioned in which medium that thing is placed, or you can say the glass is placed, then just remember that obviously when it is not mentioned the medium, that medium is placed only in air or in vacuum. So the refractive index of a medium is equals to speed of light in air or vacuum divided by speed of light in that medium. Okay, let us solve a question. Suppose light enters from air to glass and the refractive index of glass is 1.50. The value of refractive index of glass is 1.50. Just tell me what is the speed of light in glass. Find out its value, the speed of light in glass. I'm repeating, suppose light enters from air to glass. In glass, the value of refractive index of glass is 1.50. You have to tell me what is the speed of light in glass. Okay. Now, we will solve this question. Refractive index of glass is equals to speed of light in air divided by speed of light in glass. Now, we want to find out its value. Then, speed of light in glass is equals to speed of light in air divided by refractive index of glass. Now, put the values. All of you know that speed of light in air is equals to 3 into 10 raised to the power 8 meter per second divided by refractive index of glass is given 1.50. Now on solving this equation, we have value 2 into 10 raised to the power 8 meter per second. Here is the speed of light in glass. Clear? Now I'll introduce some more terms, that is optically denser medium and optically rarer medium. Denser medium, optically denser medium is different from the physical, or you can say mass density of the medium. Okay, now optically denser, optical density is the degree to which it retards or slows down the rays of light passing through it. I'm repeating, optical density is the degree to which it retards or slows down the rays of light passing through it. Okay, I'm repeating again, optically denser medium is different. Optical density of the medium is different from that of the mass density of the medium. Is that clear? It is related to this term, or it is related to light. Okay, now how can I define optically denser medium? The medium whose value of refractive index is more than that medium is optically denser medium, and optically rarer medium is the medium whose value of refractive index is smaller. Okay, or in terms of speed of light, you can also define optically denser medium and optically rarer medium. So in optically denser medium, speed of light is less, and in optically rarer medium, speed of light is more. From both these equations, you concluded that refractive index of a medium is inversely proportional. Refractive index of a medium is inversely proportional to that of speed of light in that medium. Okay, now when light goes from denser medium to rarer medium, then what happens? Draw a interface here. This is normal, this is medium first, and this is medium second. Now suppose this first medium is water and second medium is air, then that medium is denser and this medium is rarer. Can you tell me why? Because the speed of light in air is 3 into 10 raised to the power 8 meter per second, and speed of light in water is less than that of air. So this medium is denser and this medium is rarer medium. Okay, now when light goes from denser to rarer medium, it goes away from the normal. Okay, this is medium first, this medium is denser and this medium is rarer. When light goes from denser to rarer medium, it goes away from the normal. It changes its direction. This is angle of incidence, this is angle of refraction. When light goes from denser to rarer medium, then it changes its direction. It goes away from the normal. This is angle of incidence and this is angle of refraction. In this case, angle of refraction is greater than angle of incidence. Okay, now how can you remember this? when when light ray goes from denser to rarer medium, it goes away from the normal. Just remember this thing with this word, DRAW, draw. When light goes from denser to rarer medium, it goes away from the normal. Okay, now second case is, what happens when light goes from rarer to denser medium? What happens when light goes from rarer to denser medium? Okay, again I draw an interface between two media. This is medium number 1, that is, this medium is of air. This is medium number 2, and this medium is glass. All of you know the value of speed of light in air is 3 into 10 raised to the power 8 meter per second, and that in glass is 2 into 10 raised to the power 8 meter per second. Now its speed of light is less as compared to that of air. Now tell me which medium is denser or which medium is rarer. Just look here. The speed of light in this case is lesser in case of denser medium, and speed of light is more in case of optically rarer medium. So in this case, air is rarer medium and glass is denser here. Okay, now I draw a normal here. When a ray of light goes from rarer to denser medium, then it bends towards the normal. It should go like this, but it bends towards the normal. This is angle of refraction here, this is angle of incidence. In this case, angle of refraction is smaller than angle of incidence. Is it clear to all of you? Now I have a question for you. Suppose the refractive index of first medium is, the value of refractive index of first medium is 1.44. The refractive index of the value of refractive index of second medium is 1.47, and the value of refractive index of third medium is 1.33. Okay, the value of refractive index of first medium is 1.44, value of refractive index of second medium is 1.47, and value of refractive index of third medium is 1.33. You have to tell me in which of these materials does light travel faster? In which of these mediums or materials does light travel fastest? Okay, this is your question. You have to do it on your own. Just remember, I'm giving you a hint here. Refractive index is inversely proportional to, refractive index of a medium is inversely proportional to speed of light in that medium. Okay, now tell me what happens when a ray of light goes from medium 1 to medium 2 having the same value of refractive index. When ray of light goes from medium 1 to medium 2 having the same value of refractive index, it will bend, it will change its direction or not? Obviously not, because the value of refractive indices is same, so the speed of light will remain same. Then the light does not change its direction, it will go in the same direction. Just look at the activity shown below. Now students, for this activity I need a glass, a bowl and mustard oil. Now students, now look, when I pour mustard oil in the glass. Are you able to see it? Obviously, yes, you are able to see this glass full with mustard oil from this bowl. Okay, now when I pour more oil in the bowl, now tell me, are you able to see the glass? Within this reason, are you able to see the glass? Obviously, no. This happens because the mustard oil, when I pour mustard oil in this, and then I pour mustard oil in this bowl also, so their refractive index becomes same, so that this glass full with mustard oil becomes invisible. Okay, this happens just only because of equal or same refractive index.